Okay, so chapter 5 is probably something that you have some level of experience with, because I know you've been algebra to death in your high school lives. So we are going to go through this. Here is my advice to you, though. I'm hoping that you will take the time to thoroughly learn this, even if it is familiar, for a couple of reasons. First, the most imminent reason is you're going to have a test on this at some point in the future, next week or two. Second thing is the next unit, unit D, when we get there, after this unit right here, 80% of that unit involves what we're going to talk about in chapter 5. So not only will your learning this affect the very next test, it's going to affect the test immediately following. And then finally, my assumption is most all of you are heading to college algebra after this. That's why you're here. And we don't review this topic there, but we use it all the time. Okay, so we're going to talk about factoring. Okay, again, something you'll probably have some experience with, but it is really, really essential, okay, to be able to do this well. So if you have any questions, if anything arises, if I'm not explaining anything particularly well, because I know that happens, then please bring it up. Give me the question, let me do a better job so that I can help you. So what we're going to talk about in all of chapter 5 and starting in section 5.1 is we are going to talk about this thing called factoring. And specifically in section 5.1, we're going to talk about factoring the common factor, which is not very descriptive because I'm using the same word twice, once as a verb, once as a noun. Okay, so I'm going to tell you what factoring is. I'm going to assume that you know very little, and hopefully we can find a common place to start. So what factoring is, there are times when it is useful for us to write things, write expressions as a product. Remember, the word product in math means multiplication. Okay, so what we're going to do is we're going to start out with an expression and we want to write it as the multiplication of two or more things. That is our goal when we factor. And where we're going to start our discussion of factoring is the idea of having a common factor. Okay, so here's my first example. We're just going to learn by doing and asking whatever questions we need. So the instructions for every single problem that we are going to do today are these: factor completely. I'm not going to rewrite the instructions over and over. You can assume those to be the instructions for every single one of the couple dozen problems we're going to do over the course of the next 88 minutes. Here's my first one: 9x plus 18. So I've got two terms, so I'm going to use the word term a lot today. The terms of an expression are the parts that are separated by the plus and the minus sign. So I got two terms. I got the term 9x, I've got the term 18. So here's my question to you. Okay, and again, we're going to learn as we go. What factor, what number is in common to both 9x and to 18? I'm sorry? 2? No, 2 is not a factor of 9. Okay, 3 would be a factor of 9. Okay, so I picked this problem on purpose as my first one. Okay, I'm going to do what you said. I heard a lot of 3s, and that was the same in my class yesterday. So here we go. I'm factoring out the value 3. So there's two ways you can think about writing what's left over now. It just depends on how your brain works, how you see it. It doesn't really matter. You could think like this and say, okay, what am I going to put here? That times 3 gives me 9. And what times 3 gives me 9? Okay. Another way to think about it, it's the same thing. I'm just going to do the reverse. Since what we're doing when we factor, we're writing something as a product. If you notice on this, we're undistributing. Okay, so that's distributing is multiplying, so undistributing is going to be dividing. You can say 9x divided by 3 leaves 3x. 18 divided by 3 leaves 6. Now notice my instructions are to factor completely. What I have left should have no common factors. So let's look at what I have left in the parentheses. I've got 3x and I've got 6. Do they have a common factor that they share? Yes, what? 3. Again, now here's why I'm gonna also show you, in case you saw, some of you probably saw that we could have done this in one step, but I just wanted to go with this to show you that you've done nothing wrong when you pick the 3. And a lot of times you make the numbers a little more manageable and you can see the other factors after. So go with it. Don't erase. This is fantastic. So this 3 right here, I'm just going to put right there, times, and you just told me that these two things have a 3 in common. Great. So again, 3x divided by 3 leaves x. 6 divided by 3 leaves perfect. And then the last step is to say, oh, I pulled out a 3 the first time. I pulled out a 3 the second time. What's 3 times 3? 9. 9. Well, I just had more experience with this. Okay, and a couple of you probably saw this as well. 18 is 9 times 2. So we could have just done this in one step. Neither way is righter or wronger than the other. Okay. Sometimes you gotta go like this. Your numbers are such that you need to get them to be more manageable. So what I would have done is I would have factored out a 9, and 9x divided by 9 leaves x. 18 divided by 9 leaves 2, but notice we got the exact same thing, so it doesn't matter. It's just 2 roads to the same destination. So here's a problem for you, same sort of thing. If you have any questions at all about factoring, bring them up. Let's talk about it. The next one is 8x minus 12. Factor that completely, please. Okay, what factor do 8 and 12 have in common? 4. Okay, now if you do it all at once, you do it 4. But if you saw that both of these are even and you took out a 2, that is a great first step. But then you'll see that what's left over still has another 2. Okay, I'm not going to do all the problems both ways if it's possible, but just know it's totally fine to do that. Okay, so I'm going to go with 4. I'm just going to get this done in one step. 8x divided by 4 leaves 2x. Negative 12 divided by 4 leaves negative 3. Questions, comments, concerns so far? Please speak up if you have anything we need to talk about. Here's another problem. Starting off with these 3 nice, hopefully relaxing problems, and then we're going to kind of build our way up from here. 6y plus 24. What factor do 6 and 24 have in common? 6. Again, if you saw 3 or you saw 2 and started there, that's great. You're just going to go through the cycle twice. Okay, so I'm going to take out a 6. 6y divided by 6 is y. 24 divided by 6 is plus 4. Are we good with these simple doesn't mean easy, but are we good with these simple examples so far? All right, I'm trusting you to be telling me the truth because there's no reason to lie. It's here. It's on the ground. Oh, there it is. I just didn't look down. Oh, this is working good today. All right, so here's the next one. The purpose of this problem is factoring is the same process, whether we have 2 terms or in this problem, we have more than 2 terms. So factor this completely, please. Okay, factor out the common factor, 28x squared plus 21x plus 35. Okay, so among 28, 21, and 35, what factor do those three terms have in common? 7, yeah. Don't be afraid. If you need to, grab your calculator and mess around with the numbers on my test. Okay, everything will be factorable. Okay, there's no tricks or gimmicks. I'm just trying to teach you how to factor. I'm not trying to teach you how to be frustrated. Okay, so everything will be factorable on my test. So just grab your calculator and do your multiplication. So 28 divided by 7 leaves 4x squared. 21 divided by 7 leaves 3x. 35 divided by 7 is 5. And there's my answer. Anybody get something different that we need to talk about? I've got one more where we're just going to deal with the coefficients, and then we're going to talk about variables. After this, I have a purpose for this problem. So 15x squared plus 25x plus 5. All right, what's the common factor among those three terms right there? Okay, 5. Now here's the reason why I gave this problem. Okay, because I want to alert you to a common mistake. Remember, we are here to learn. If you made this mistake, don't beat yourself up. Just make a note that you don't want to do this. So we're going to factor out this 5. And I think the first two terms don't present us any real big deal. 15 divided by 5 is 3x squared. 25 divided by 5 is 5x. Now here's where students sometimes make a mistake. I factor out the 5. What's 5 divided by 5? Okay, 1. Now, I know that we see the 1 and we're like, okay, that's not really a whole lot. And so we'll just put our parentheses here. But here's what you've done. You've changed something from 3 terms into something that has only 2. So you've changed the whole structure of the problem. That's wrong. So when this happens, and it will on occasion, 5 divided by 5 is 1. So you have to put the plus 1 there. So if you left the plus 1 off, which is a common mistake, okay, make sure to make a note that when you factor out the whole term, you still need to put a 1 there, okay? Because, and I forgot to mention this earlier, sorry, I'm just so excited to talk about factoring, is you can always check your answers by remultiplying. So when I redistribute this 5, if you want to check, okay, you should get exactly what you started with. And if you leave this term off, you won't be able to do that. Okay, so that's why it's very important. Questions about that problem right there? All right, next, variables. Okay, so that's all fun and good with coefficients, and we'll come back to that. But now I have this. I have 5x to the 4th and then plus 4x squared. 5x to the 4th plus 4x squared. We're going to factor out the common factor. We're going to factor completely. Now, my 5 and my 4, they don't have anything in common because I just wanted to focus on the variables on this particular problem. Simple question. How many x's are there in the first term? There's 4. How many x's are there in the second term? 2. So if I need to factor out the same amount from both of them, how many x's can they both give me? 2, okay? So just a little note, it's always the lowest power. So it's always the lowest power. That's why I haven't mentioned it up till now. You'll notice on these previous 2 problems, there's 2 x's in this term, there's 1 x in this term, but there's no x's in the last one in both of these problems. So that's why I didn't even ask about variables up till now, is because there wasn't any variable that all the terms had in common. So I'm going to take out the 2 x's. You just told me that they both could donate 2. So I have 5x to the 4th. I started with 4 x's. I factored out 2. How many x's are left in this first term? Okay, so I've got 5x squared. And remember, we reviewed real quick before our last test the properties of exponents. When I remultiply, I add the powers. So 2 plus 2 should give me 4. Okay, so that's the quick check right there. You add the powers when you multiply things. Okay, the second term. I had 2 x's in this term. I factored out 2 x's. How many x's are in this term right here? None. Yes. So it's just 4. Don't write 4x. Okay, I know sometimes we want to have kind of that remnant there. That's wrong. You're adding in another x into the problem. Okay, so it's just 4 because x squared times 4 would be 4x squared. If there's a question, please stop me. I'm just going to keep going because I'm loving factoring. It's so fantastic. So 7y to the 6th minus 5y to the 3rd. Factor that completely for me. Something I can help you with? The lowest exponent will always be what you factor out. Okay, so this has an exponent 4. This has an exponent 2. So I'm going to factor out x squared. That's the lowest power. Okay, does that answer your question? So on this particular problem, how many y's can I factor out? Yeah, that's the lowest power. 3, right here. So I'm going to factor out y to the 3rd. Again, 7 and 5 don't have anything in common. The last couple problems we do will be everything, coefficients and variables. It's going to be a bonanza of factoring. So now I am going to go ahead and factor out these 3 y's. So 7y to the 6th, when I factor out the 3 y's, what does the first term become? 3 plus 3 is 6. Minus 5y to the 3rd, when I factor out the 3 y's, what does this last term become? Excellent. Sounds like you're doing good, but if you're not, the word that I'm trying to say, that happens more and more as I get older, it's just get involved with me, is I guess what I'm trying to say. All right, so here is our next problem. Again, just extra terms. To have even more fun right here, and we're also going to have something in common in the coefficients. So here you go. This is the factoring party you've been waiting for. So 24p squared minus 9p to the 3rd plus 6p to the 4th. Okay, so there's something in common with the coefficients. There's something in common with the p's. Okay, so do both. (24, 9, and 6. What factor do those 3 terms have in common? 3. And then p squared, p 3rd, p 4th. How many p's? Just consider them one at a time. Don't look at the whole term, kind of overwhelms. Just look at the coefficients first, and then look at the p's. And then in a couple problems, we're going to have another variable just for even more fun. So then you'll look at those. Okay, just one thing at a time. So here we go. 24 divided by 3 is 8. How many p's are left in this first term? None. Minus 9 divided by 3 is 3. How many p's are left in this second term? Yeah, we started with 3. We took 2 out, so I'm left with 1. And then 6 divided by 3 is 2. And how many p's are left in the last term? P squared. 2 plus 2 is 4. Yeah, great. Okay, so we're taking out what's in common. So I'm looking at the powers. There's 2 p's here. There's 3 here. There's 4 here. Okay, so I need to take an amount that they can all give. So I can't take 4 p's out because this one doesn't have enough, right? I can't take 3 out because this one doesn't have enough. Does that make sense? Okay, great. Great question. Good to be clear on these things. Love it. All right, I have one more example, and then I've just got 2 more for you, and then we're going to move on to the next part of factoring. So if you have any questions about factoring out common factors, now is the time to get them. Yes?
Okay, so like
Not right now, because we're factoring out a positive thing. So a positive times a positive, positive. Positive times a negative, negative. Positive times a positive, positive. Okay, but hold that question, because there is a situation where we will address the signs. Okay, it's a really good question. All right, but before we do that, here's my final factoring the common factor problem. So let's say I have m squared n to the fourth, and then plus n to the sixth, n to the third. The purpose of this example is what to do when we have more than one variable. So write it down, and then we'll talk. I don't think it's going to be too much of a surprise, but I want to make sure I cover all of our bases. So again, I'm just going to look at the m's first and then the n's. I'm just going to do one at a time. So as far as the m's, how many m's can I factor out? 2. M squared, the smallest power. Always the smallest power. How many n's can I factor out? Yep, always the smallest power. Now we'll see what's left. Before we see what's left, anybody conflicted about where this came from? We okay? Okay. 2 m's here, we factored out 2 m's. How many m's are left in the first term? 4 n's, we factored out 3 n's. How many n's are left in the first term? Great. Plus 6 m's, we factored 2 out, so that is going to be 4. 4 plus 2 is 6. And then we started with 3 n's, we factored 3 n's out, boom, no more. All right, here's your second to last common factor problem. Again, so get those questions in. You need to. Don't be shy. So this is 9x to the third y squared minus 3x squared y squared plus 6x squared y to the fifth. We've got 3 terms, we've got coefficients with stuff in common, we've got 2 variables, everything. Yes. Okay, so your question is what again? So this is the problem that you're referring to, correct? Okay, so you said earlier I talked about changing the problem. That was a whole term. So are you talking about now, what about here? We are not changing the problem. I have 2 terms. I have this term right here, and I have this term. Remember, the terms are things separated by the plus or minus signs. Okay, so they're like train cars. Okay, and this is the connector. And so now in my parentheses, do I still have 2 terms? Well, I've got this term. It's smaller now, but I still have 1 term, and I have this term, and the plus sign is still there. So I've not changed the problem. And so what I was talking about earlier is when I factor out everything for the term, the temptation is, well, I've factored everything out, there's nothing left. But there's the 1. We've got to keep that term present. Okay, does that make sense? Do you see the difference? Okay, great question. Thank you for asking it. Okay, so on this problem right here, we're gonna go through each different factor and see what's going on. I've got 9, 3, 6. What's in common to 9, 3, 6? 3. They all have a 3 as part of their product. I've got x third, x squared, x squared. So how many x's? Lowest power always. Y squared, y to the fifth. Always the lowest power. So in my parentheses, to address the question that was just asked, I should still have 3 terms. Okay, so let's not lose a term. So 9 divided by 3 is 3. 3 x's, I factored out 2, I'm left with x. I factored out all the y's. That's what's left for my first term. Minus 3 divided by 3 is 1. Started with 2 x's, factored out 2 x's, no more x's. Started with 2 y's, factored out 2 y's, no more y's. So the middle term I need to have this is minus 1. And then plus 6 divided by 3 is 2. Started with 2x's, factored out 2x's, no more x's. 5y's, factored out 2, leaves me 3. I got one more. It's going to be like this. So if you made a mistake, if you see it now, you're going to get your chance to work through it. Okay, so it's the same sort of thing. Again, interact with me. Let me know what I can be doing to be more helpful. So here it is, 25, a to the 4th, b to the 3rd, plus 15, a to the 5th, b to the something, 6, there we go. And then minus 20, a to the 4th, b to the 6th. Okay, first, 25, 15, 20, what factor? And then I think I can take out 4 A's, that's the lowest power, and then I can take out 3 B's, that's the lowest power. Anybody have anything different that they factored out that we need to talk about? 25 divided by 5 is 5. 4 A's, no more A's. 3 B's, no more B's. So the first term is just 5. Plus 15 divided by 5 is 3. 5 A's, 4 A's, I need one more. 6 B's, 3 B's, I need 3 more. And then last but not least, 20 divided by 5 is 4. Then I need a little more room. And then 4 A's, no more A's. 6 B's, 3 B's, I need 3 more. And there we go. All right, so that's factoring the common factor. So the next two things we're going to do are basically an application of that. So if you're tracking with what's going on so far, there's not going to be much different going on. The next thing is when we come back on Tuesday next week, we're going to continue exploring factoring. There are situations where I want to make sure that the signs are an appropriate way. So for instance, this is my problem: negative x squared plus 5x minus 11. You don't need to know this word. This is just bonus content for you today. The term with the highest power, the 2 here is the highest power. The term with the highest power is called the leading term. Math people like to label everything. I'm not going to ask you, I'm not going to quiz you on that. I'm just mentioning it because when we factor things with 3 terms next week, it's handy when our leading term is not negative. It makes the thought process a little clearer. Okay, so when you're doing your homework, my math lab is going to ask you to do this a few times just so you're comfortable. I want to make sure my leading term is positive. So what I'm going to do is I'm going to factor out that negative or a -1. If you want to write a 1 there, that's totally great. I'm not going to. So this addresses the question somebody asked earlier about the signs. Okay, we haven't done this up till this point. Everything we factored out up to this point has been positive. But now when I factor out a negative divided by a negative leaves me what for my first term? Positive x squared. A positive divided by a negative leaves me negative 5x. And a negative divided by a negative leaves me positive 11. You just change the signs now of the things in parentheses. So just so that you have one that you work through and have the tactile experience of writing it down. Here's one for you. It's no different than my example. You just get to do it. So this is negative y squared minus 7y and then plus 13. All right, so I'm just going to go through writing it down. The leading term is negative. I'm not going to want that in the future when we talk about factoring these things called trinomials. So I'm going to factor the negative out. So that's going to leave me a positive y squared, a positive 7y, and a negative 13 when I do it. We'll change the signs. Still doing okay? All right, well, the next things I show you are steps in a process that we are going to use again on Tuesday. Okay, so there is a place that we're driving to right now. So we're just going to take it kind of one step at a time. So here's another factoring the common factor problem, but it's going to look a little bit different. So here it is. I've got x minus 5 and then times x plus 6 and then plus, and then I have x minus 5 times 2x plus 5. So something like this is going to be our last step in a bigger process. Okay, so I'm just trying to boil this down to one thing at a time instead of presenting a whole big new thing. So we're going to factor out the common factor. So again, notice I underlined this earlier. I have two terms here, even though the terms look different than what we had before. So here's my plus sign right here. Remember, the terms are things that are multiplied together. These two things are being multiplied together, so that is my first term. Even though each term is a binomial, it's okay, it's still a term. And then these two things are being multiplied together, so these two things form a term. So we're still doing the same thing we were. It just looks a little grosser. So looking at the two terms that I've underlined here, do you see anything that is exactly the same about both of them? X minus 5. Awesome. Yeah. So what we're going to do is we're going to factor out that x minus 5. I've got an x minus 5 right here, and I've got an x minus 5 right there. So we're going to factor it out, just like we factored out, well, it's not right here, but in your notes, the x's and the 3's and all those other things we've been factoring out. So I'm factoring out, this has one x minus 5, this has a single x minus 5. So I'm factoring out a single x minus 5. It's not x minus 5 squared. Sometimes that is something students add. We're not multiplying these two things together. We're factoring it out. And they each just have one to give. Okay, so for my first term, I'm going to cover it up. When I factor out the x minus 5, what's left from this first term? X plus 6, right? And then my plus. The second term, when I factor out the x minus 5, what's left right there? Excellent. And then the last thing is we're just going to make this look a little neater in here. There's some like terms that I can combine because of this plus sign that was between the two terms. So I have x plus 2x is 3 of them, and then 6 plus 5 is 11. So again, this is in a bigger process that we talk about on next Tuesday. This is kind of our last step that we will be using. In just a minute, after we do one more of these, we're going to talk about the middle step. Yes.
I think you have x minus 5, which is in both things, so you're not taking it out. But then you combine it both of those sections. Is it not like having a new question?
that's a really good that's a really good question, and I have not changed the problem. It looks different structurally, but if we did the following, if we multiply these together, and I was going to mention this when we get to the very beginning of section 5.2. Does anyone remember what we do when we multiply two things that are binomials together? Some teachers give you an acronym to help remember. FOIL, yes. Okay, if you don't know FOIL, it's okay. We'll talk about it, but all you have to remember is you got to multiply all four terms. So if I multiply all four terms together right here, you're gonna get your polynomial. If I did the same thing up here, see, this isn't simplified. That's the thing. I understand your question. That's why this is a little confusing. This is not simplified. This is part of a bigger problem. And I'm showing you one particular step, so we're doing one thing at a time. Okay, but if I multiplied these things together and added everything together, it would be the same thing as this, I promise. Okay, so we've not changed the problem. Okay, great question. I love that you're processing it. All right, here's one like that for you. Okay, same sort of thing. So 3x minus 2 times x plus 1 plus, and then 2x minus 5 times 3x minus 2. Same sort of thing we just did. Just different terms. What is the thing that both of these terms here have in common? Okay, there's a 3x minus 2 here. There's a 3x minus 2 here. Yes, they both have that in common. That's excellent. So I'm going to factor out that 3x minus 2. Again, there's no power on this. They both just have a single 3x minus 2. So there's a single 3x minus 2 right here. Then, when I factor that out, what's left from the first term? Yep, just the x plus 1. It's right there. Plus, and I'll just draw a little arrow so we remember that that's there. And then what's left from the second term? Yes, cover that up, 2x minus 5. So 3x minus 2. And then I have like terms. So x and 2x is 3x. And then 1 minus 5 is negative 4. So there's one more thing from this first section that all kind of incorporates factoring the common factor. And once again, this is kind of the middle step on a bigger process that we're going to talk about on Tuesday. Okay, so what we're going to do now is we're going to use this ability we've now reminded ourselves of, or that we're learning, factoring the common factor, to do something called factoring by grouping. And so a question that occurs right off the bat is, hey, Perkins, when am I going to use factoring by grouping? How do I know? What's the clue? That's a great question. You know that you're going to factor by grouping when something has 4 terms. Okay? In this class, that will be the time that you know. There's not going to be more terms than that or anything like that. When you have something with 4 terms, that's your clue that this is going to be a grouping problem. So now the next question is, okay, well, that sounds fantastic, but what does factoring by grouping mean? So excellent. So I've got ax minus ay plus bx minus by. I'm keeping these things we're factoring hopefully relatively simple, just because I want you to be learning the grouping. So I'm not putting all sorts of powers for most of the problems or anything like that. I just want us to grasp what it means to do grouping. Okay, so we've been factoring out the common factor. Here's my question. I've got 4 terms. is there something that is in common to every one of the four terms? Is there something the same in all four? No, right? There's nothing the same. I mean, we've got an A, but it's only in the first two. Right? We've got Y's, but they're only in these two. So there's nothing that is in all four. So there's nothing in common to everything. Otherwise, we would factor it out. So what we're going to do, though, because we don't want to, again, we don't want to leave it like this. There's times when I want to write this as a product of two things. So here's what we're going to do. This is the grouping step. I'm going to, instead of considering all four terms, I'm going to consider the first two terms as a unit. And then I'm going to group the last two terms as a unit. That's grouping. Okay, so this is the grouping step right here. I'm just going to consider the first two terms. I'm going to consider the last two terms, and I'm not going to consider anything else. Okay, so for my first two terms, what's in common to these right here? Okay, yeah, this is what we've been doing. Okay, so we're just applying it now. So there's an A in common. AX, I factor out the A, there's X, minus AY, I factor out the A, there's Y. What's in common to the last two terms? Okay. BX, I factor out the B, I have an X left, minus BY, I factor out the B, there's a Y left. So like I said, this is the middle step of a bigger process, which takes us to what we were just doing a moment ago, which I told you was the last step of a bigger process. So this is an extremely similar problem to that one right there. I'm now going to factor again. What's in common to these two terms right here? X minus 1. They both have the same thing. So I've taken this thing with four terms, I've grouped, I've created two terms, and now the X minus Y is in common. And then what's left from the first term when I cover up is A. What's left from the second term when I cover up is B. And again, if you want to check, okay, because we're getting a little closer to the full style problem, if you want to check, if you do first, outers, inners, lasts here, then you're going to get these four terms right here. Okay. So what we've done is we've taken this thing with four terms and we've written it as the product of two things, which was our goal. Okay. And that'll have handy usefulness to us, especially when we get into the next unit, Unit D, when we come back whenever this test is. So here's a problem just like that for you. Again, keeping things as simple as I can so that we're not compounding things that we're learning. So here's yours, 3m minus 3n plus xm minus xn. Okay, so go through the steps, give it a try, see how it goes. Once again, there's not something in common to all four terms. So I'm going to consider the first two as a group. I'm going to consider the last two as a group. What's in common to the first two terms? Okay, 3, staring us in the face. So 3m, take out the 3, I'm left with m. 3n, take out the 3, I'm left with n. What's in common to the last pair of terms? X. So xm, take out the x, I'm left with m. xn, take out the x, I'm left with n. Now I've taken my thing with four terms, it's become something with two terms. Here's my first term, plus, here's my second term. And what's in common to those two terms right there? Grouping only works if you get the exact same thing in parentheses. Okay, and again, I've told you everything on your test that I give you is going to be factorable. So if you don't get the same thing in parentheses, you made an arithmetic mistake, so just go back. Okay, no tricks or gimmicks. And so when I factor out the m minus n, got 3. When I factor out the m minus n, plus x. So very good x. Here's another one to try and ask questions about if you need to. Two ax plus 4bx plus 3ay plus 6by. All right, give that a try. Lots of letters going on with that one. All right, once again, going to group the first two, going to group the last two. When I group the first two, I've got 2ax, 4bx. What's in common to those two terms right there? Okay. Between 2 and 4, there's a 2, and then they both have x's to give. So we'll do that. So 2ax, I took out the 2 and the x, so I'm left with a. 4 divided by 2 leaves 2, and then bx, I took out the x, leaves me b. What's in common to 3ay and 6by? The 3 and 6, they have a 3 in common, and then ay and by, they both have a y in common. So once again, 3ay, I took out the 3 and the y, so that leaves a. 6 divided by 3 is 2. by, I took out the y, that leaves me b. And once again, the grouping worked. I've got the exact same thing in parentheses. Yes? Yeah, it would be different first. We always want to factor completely. Okay, so we want to take out everything that's in common. But if I did not take out the x, then what I would have here is I would have ax plus 2bx. Now I have a problem because I don't have, these are not exactly the same now. So I can't go any further with this. I can't factor anything else. Okay, so I would if I don't factor this completely, then I create a barrier that I can't go through. Okay, so great question. I'm glad you asked it. So we always want to factor completely. So now I have the same thing in the parentheses. The a plus the 2b, we'll factor that out. And then when I factor a plus 2b from the first term, what's left from the first term? Yep, there it is, 2x. When I factor the a plus 2b, what's left from the second term? Okay, great. Excellent work. All right, so, all right. Next one, I've got another example for myself, and then I've got, I think, 2 more or 3 more for you, and we will be done with our main section for the day, and we're going to do the first little bit of the next section. So every one of these problems, I don't know if you've noticed or wanted to ask about it, there's been a plus in between the two. Now, I haven't even addressed it, we just kind of assumed it. So when would that not be a plus sign? And that would be a great question if it was on your mind. So here's my example. to help us look at this. 3x minus 3y minus ax plus ay. Again, simple terms because I want us to notice something about the structure of this problem. Okay, so one thing, I got 4 terms. There's nothing in common to all 4 terms. So I'm going to group the first 2 and I'm going to group the last 2. So now when I group the first 2, I'm sure you would tell me that between 3x and 3y, they've got a 3 in common. 3x divided by 3 leaves x. Negative 3y divided by 3 leaves negative y. Now here's the thing, as you do more of these, that you can learn to notice, okay? This is the important part to notice. I've got a positive x term and I've got a negative y term. Would everybody agree with that? Positive x, negative y. Let's look at the next pair of terms. This is my x term. What's the sign on this? Negative. This one's positive. What's the sign on this one? This one's negative. So what I notice, okay, is that my x and my y term here have the opposite sign of my x and my y term here. Does that make sense what I'm looking at? Okay, if you can learn to, that's the thing to learn here, is just look ahead at your signs. I've got a positive x, negative y, I've got a negative x, positive y. When you have opposite signs, okay, so I'm just gonna, I don't know if this is super clear, I'm just gonna draw a little arrow and I'm gonna put opposite signs. When you have opposite signs, that's the clue that we are going to go ahead and we're going to factor out a negative something. So I got to make the signs line up. Just as was asked previously, I have to have the exact same thing in parentheses for grouping the word. And so now when I factor out the negative something, they've got an a in common, so it's going to be a negative a. So here we go. I've got a negative ax. I factored out the negative a. A negative divided by a negative leaves me positive x, which is what I wanted. Oh, good. I achieved my goal. I've got a positive ay divided by a negative a. So positive divided by a negative is negative y. Again, I've achieved my goal. I've got my signs lined up. The grouping once again worked. I've got the exact same thing in parentheses here for both of them. What's left from the first term is a 3. From the second term, a minus a. So I've got just two problems like this for you to do, and then we're just about done. So here is yours. Try this one. It goes like this. AB minus 7a minus 5b plus 35. All right, my grouping. My first 2 terms, I can factor out an a, and ab divided by a leaves b. Negative 7a divided by a leaves negative 7. Then I notice, again, just like the previous one, my b term here is positive, my b term here is negative. They have the opposite signs. So that's my clue that I need to factor out a negative something. And so between 5 and 35, they both have a 5 in common. So negative 5b divided by negative 5, a negative divided by a negative is a positive b. Positive 35 divided by negative 5, a positive divided by a negative is negative 7. And again, the grouping worked. I've got the b minus 7 right there. I got an a from the first, and then a minus 5 from the second. Any of these you can be checking, do your first outers, inners, last. When you leave this next test, you should leave knowing whether you got a problem right or wrong, because you can just real quick multiply those two things back together and see how you did. All right, one more problem. M to the third plus 4m squared minus 6m minus 24. Okay, this is just another example of noticing the signs. So the factoring out the common factor, my hope is at this point, that's not the big deal. You have plenty of time to practice. So I've got 3 m's, I've got 2 m's, so I can factor out 2 of them. It's always the smallest power. Started with 3, took out 2, left with m. 4m squared, took out the m squared, left with 4. Again, I'm looking ahead. My m term is positive, my m term is negative. There's my clue that I have to go ahead and factor out a negative something. And then what's common between 6 and 24 is 6. So negative divided by a negative leaves a positive m. Negative divided by a negative leaves a positive 4. Grouping worked. That's great news for me. And there's my final answer. Last problem for this section. I've got one more thing I need to clue you in on because I don't want you to encounter extra frustration as you're learning this. So here's the last problem. We're going to do this one together. P squared q squared minus 10 minus 2q squared plus 5p squared. This is our last factoring by grouping for this section. So the question I have for you is this. When I go to group here, and I look at my first 2 terms and I look at my last 2 terms, p squared q squared minus 10, what's in common to those 2 things right there? Okay, nothing. So that becomes a problem. If I can't factor out anything, then I can't get it so that I have parentheses that I can factor something out. So again, on the test, everything's going to be factorable. So if you encounter a situation like this, where you've got 4 terms, you're supposed to factor by grouping, but your first 2 terms don't have anything in common, here's the simple solution. Just change the order of the terms. Okay, so this is just to let you know that not every arrangement of 4 terms is factorable directly. So what I'm going to do is I'm just going to take this minus 10 and I'm just going to throw it to the end. The reason I'm choosing to do that is if I get rid of the minus 10, then I'm going to have the p squared q squared and then the minus 2q squared right next to each other. They have something in common. So let me rewrite this. So all I did, I have not done anything different. I just changed the order of the terms, which is a legal maneuver. You can always add things in any order you want. So I took the negative 10 here and I threw the negative 10 on the end. Now I have an arrangement that things are in common. In my first two terms, I have q squared. When I take the q squared out of this first term, I'm left with p squared. When I take the q squared out of the second term, I have a -2. My p squared term is positive, my p squared term is positive here, so this is not the situation where I have to take a negative out. And then what's common from 5 and 10 is 5. When I take the 5 out of the 5p squared, I'm left with p squared. When I take the 5 out of the -10, I have -2. So we created an arrangement of my terms that allowed the grouping to work. So that's good news. We're just about done. When I take the p squared -2 out of both of these, I'm left with q squared and then +5. And there is my factor. All right, that's the end of section 5.1. Stop.